Hey guys, this is Jagan signing here from Tech Tutor. In this video podcast, we're going to discuss the use of weak pointer. And in fact, there is a particular issue with a shared pointer. In one particular scenario, the shared pointer will not release the memory. So that is what we're going to see, and we're going to overcome that issue with the weak pointer. And let's understand this by writing a simple program. Let me include the necessary headers. IO stream, string, and the memory. Basically, the memory has the shared pointer using namespace std. Okay, I'm going to define a parent class, and it's going to have a shared pointer to the child class. Let the parent have a name. Okay, and I'm going to define a parent constructor and destructor, and I'm going to pass a name to it, name of parent. Okay, and I'm going to initialize that in the initializer list, name of parent. Okay, that's done, and I'm going to do a print. Let's remove this, and over here it's going to be parent name, and it's going to be constructor. Okay, and we are going to define the destructor now. Okay, and let's replace this constructor with the destructor. Okay, we're done, and apart from this, I'm going to define a simple function called setChild, and I'm going to pass a shared pointer to this child. Okay, and this child is assigned with a child. Okay, it's a simple code, and I'm going to define a child class, and it's going to have a private members like this, name, and it's going to have a shared pointer reference to the parent, one for dad and another for mom. Okay, and let's define a child constructor. Now the child constructor is going to take 3 arguments, name of child, and it's going to take a shared pointer to parent, and it's going to be father, it's going to be mother. Okay, fine, and I'm going to initialize them here. Name is name of child, and dad is father, mom is mother. Okay, we're done, and I'm going to put some print statements. Child, let's print the name, and it's a constructor. Okay, now let's go ahead and define the child destructor. Or here we'll just copy paste it. Let's say this is destructor. Okay, and that's it. Our child class definition is done. Let's go ahead and use that in the main. In the main, I'm going to declare 3 shared pointers. Parent, it's going to be dad. Over here we're going to say new parent, father, and there is going to be one mom, this is mother. Okay, and there is going to be one child, this is of type child. of type child, and this is going to be child, and we need to pass the mom and father and mother to the dad and mom shared pointers to the child constructor. We are done. Now let's do a dad set child and pass the child. We'll do the same thing with the mom object. We're done. Let's return 0. Okay, let's look at the code again. Over here we have a child reference, and the child class is defined in the bottom, so it's a forward reference, so we need to have a forward declaration class child. Okay, we are done. Now let's compile and see if there are any compilation errors, and let's indicate we are interested in using the C++ features. GNU++ 11. Okay, we have compiled, and if you notice, only the constructor messages are printed, but we are using shared pointer. When we use shared pointer, it is supposed to free up that objects, right? These objects, the father object, mother object, and child object. But looks like it is not doing that in this scenario. The reason for that is there is some kind of cyclic dependency here. Let me explain that here. If you notice, the parent has a dependency to the child object, and child object has a dependency to dad as well as mom. Mom in turn has one reference to child, and dad also has one reference to the child. So the way the shared pointer works is it internally uses some kind of mechanism called reference counting. So when the reference count becomes 0, that's when actually the shared pointer will know that nobody is referring to these objects and these needs to be freed up. But in this case, what would happen is, because there is a cyclic dependency from the parent to child and child to parent, unless the parent object is deleted, the child object can't be deleted, and unless the child object is deleted, the parent object can't be deleted. So there is a issue with the design. So whenever you have this kind of cyclic dependency, the reference count mechanism is not going to work. So I would say this is more of a design issue. To overcome this design issue, there is something called weak pointer. Okay. So all we have to do is we have to break the cycle. We can break the cycle by using weak pointer in case of parent. Okay, so I just replaced the shared pointer with the weak pointer. So basically the weak pointers are not reference counted. Okay, so unlike the shared pointers are always reference counted, whereas the weak pointers are not reference counted, which means the parent object doesn't have a strong reference on those object. Basically the ownership is not shared. They can access it, but they don't own it. That's the meaning of weak pointer. And also we have to be very careful that whenever we are using a weak pointer, we have to ensure the object is valid actually, because the actual object may go out of scope anytime. Okay, let's compile the code. Okay, we have compiled, and now if you notice, all the objects are being deleted. So this is the use of weak pointer, and we have to know the limitations of shared pointer, and the only limitation of shared pointer is this particular cyclic dependency, and in fact it's a design issue. And if you like this video, you can subscribe to my YouTube channel so that you can watch more such videos. Thank you.